already informed to all of you, today we are going to be discussing about feature engineering. All right. So we'll start with the very fundamental. All right. Rather than asking a simple question of what is feature engineering, which is probably what you would expect, I would ask a two-part question. What is feature engineering? Why do we need to do feature engineering? And I would request Sharat to please take the center stage and start off.
Thank you, Nitin. Good evening, everyone, once again, and welcome back to the channel. Hope you're learning, hope you're enjoying. And coming to the question, what is feature engineering? Now, very common point. Again, we speak about the features that we require for model building and trying to bring a solution into the the business problem. But if I take a feature basically means your column in your data set. So if I take any field or a column, I need to ensure that it is relevant in solving the business problem. When we look into the raw data, the business can give us in different forms of data. I mean, there could be ocean of data fields that are collected by the organization. We will look into only those things which are relevant. And this raw data may not be in an appropriate form for us to directly consume. For example, in my case, when I was working on this automobile prediction models where we were trying to predict the fuel efficiency of the vehicle, we had a very simple example. We had data of purchase of the vehicle. We were dealing with the second stage. So data of purchase of the vehicle was there. And we also had the data of handing over to the second stage. So data of selling. The customer is giving the car to us. Now, I have these two, but this does not make really any meaningful sense when I'm trying to predict the fuel efficiency of the vehicle. So feature engineering is trying to construct a new feature which can actually be more sensible for model building. So in our case, in this case example, I was simply doing subtraction of the two fields, the current date or the sale date minus the purchase date. This gives the total duration, age of the vehicle. So this is one example of dealing with the features that we are trying to work in our model, because fuel efficiency is directly getting influenced by the age of the vehicle. But if I use the raw data, which is given, I may not be able to capture that kind of a correlation between these two fields. So that is basically to answer the question on feature engineering.
Yeah. So if you noticed, audience, I had asked two questions, and there was a reason for asking two questions, what and why, because the what and why gets answered together. If you've noticed Sharat's response, the what and why get answered is for that reason I had posted it that way. So Barney, can you just add a little more with your experience of why feature engineering, more to do with why feature engineering, of course, what we've understood in your experience.
Sure, absolutely, Nitin. So feature engineering as such includes a lot of things. It is an amalgam of feature understanding. That means understanding the columns or the variables that you have. It includes feature cleansing, wherein you try to clean the features. And we spoke extensively about that when it came to our data cleansing aspects or data pre-processing. Then we have something called as feature scaling. Feature scaling means if you have two variables of different scales, then you do normalization or standardization. If you have outliers, if you're retaining them, you do robust scaling, etc. Feature engineering also includes feature construction. I'll come to that in a moment. And we have feature selection, feature transformation. All these are part of your feature engineering aspects. And within this, feature construction is something on which people have to spend significant amount of time. Because feature construction is all about coming up with new features, given the existing features which the client has given to us. And the raw data which we get from the customer is probably the first thing that one has to attack. And within our data set, we had a column called as income, which was following exponential distribution. So we had to do feature transformation, which is part of feature engineering. And we had to take a log of that to be able to effectively capture that specific feature. And, in certain cases, there is not a single person. I mean, single person would not apply for the loan. You might also have co-applicants. So when you look at the total income, when you look at the applicant's income and the co-applicant's income, only when you combine, you get to know the total income. As opposed to using two columns, which is applicant's income and the co-applicant's income, when you combine these, you get something called as total income. And that total income as a variable, if you use that, then instead of using two features or two variables, you're ending up using only one. That is a total income. And on that total income, you might want to do a log of that, log of total income, so as to get more details, or so as to capture the information within that data in a much better manner. Having said that, we also have something called as feature selection, in which you might want to shortlist the laundry list of features into sizable features, which are very important. And in the due course of doing that, you have a few statistical ways of doing that. And then there are a few other techniques, such as principal component analysis, which is one of the dimension reduction techniques. You might want to apply LDA, linear discriminant analysis, factor analysis. All these are used to reduce the features. Not just that, we have a few deep learning techniques when it comes to feature selection, which are most widely used and most preferred whenever you have complicated data. When you feel that, you know what, when I look at the scatter plot, there is no correlation which exists. And when I look at the probability distributions, I cannot figure out whether the data are uniformly distributed or normally distributed or whatever be it. And if you feel that through EDA, you will be able to figure out whether your data set is very complicated or not having any patterns as such, or it's very difficult for you to figure out the patterns when you do your graphical representation, to figure out the correlations and all that. Then people use techniques such as autoencoders. And prior to that, people were using RBM models, restricted Boltzmann machines, which would take your original data set of probably 100 features, and then it would compress them into probably 10 features or 20 features based on the number that you give. On similar lines, autoencoders would also take huge bunch of features, and it would reduce them into less number of features. This is an automated way of reducing your features. But then the flip side of this is that you lose the interpretability. For example, if you take the income of the applicant and income of the co-applicant, when you add these two, you get total income. Here it's pretty clear on what are the features that you're working on. But the moment you resort to these kind of techniques, be it PCA or be it LDA or be it factor analysis or restricted Boltzmann machines, RBMs or autoencoders, what happens is they transform the variable to such an extent that you lose the interpretability. You don't know what are the new features which your model has come up with. And if you're using PCA or factor analysis, to some extent, probably you can figure out what are the new features to some extent, if you're lucky. But when you use RBMs or autoencoders, it is taken that it is black box. Deep learning techniques are black box, meaning the new features which would be extracted from the existing features, you will have absolutely no clue on what they are. So given this context, far too many things go into feature engineering, especially when it comes to feature selection or feature construction, because a lot of domain knowledge and a lot of complicated techniques would be used. But is it worth using them? Absolutely. And why am I saying it's absolutely worth using? Because a lot of customers expect the prediction results to happen within split second, especially when it comes to stock market kind of data, or if you're building models to predict the credit card fraud, etc., where real time you should be able to give the results. And in those kind of scenarios, it actually makes sense to compress the features using certain feature selection techniques that I've just spoken about. Yeah. Thank you so much.